Now let me do an example where you actually go and apply steps 3 and 4 as we go further, and then another one where I want you to be very, it's a simple problem, but I want to show you what happens. Okay, so on this next expression here, what is the length of RT? Okay, what is the length of RT? Now most of you are used to going to say, oh, well, length of RT is 16. And you're going to want to put that right in your answer and say, there, I'm done. Well, what you've done is exactly what I said is not the focus of the course. You've jumped right down to here to solve the answer. And you've skipped steps 1, 2, and 3. You have ignored the geometry part of the course and jumped right to the algebraic or the solution part. And again, that's not the emphasis of the course. The emphasis is not, can you come up with 16? The emphasis is, well, can you prove and explain that 16 is correct? And how can you prove or explain that? Only with postulates, theorems, or definitions. So what should your problem look like? Well, if we go to step 1, what's the first thing that I'm supposed to do according to step 1? I'm supposed to use a postulate, theorem, or definition that applies to this problem. So as I look at this, because it's a line and it's line segment, I notice, oh, well, that would be segment addition postulate. That would apply. Then once I recognize it, I then write the algebraic expression based on the postulate, no numbers. In other words, I don't write 12 plus 4 equals 16. I don't write that. That's not the algebraic expression that comes from the geometric understanding of the figure. What I understand about this figure, because these 3 points are on the same line and one is in between the other two, I know then that the two parts, so I know then that RS plus ST is going to equal RT. That's the geometry part. How do you know that? Well, because the segment addition postulate says so. So the segment addition postulate allows me, or gives the reason behind this. Now that's steps 1 and 2. That tells me that you understand the geometry course that we're talking about. Now the rest is algebra. Now I can substitute in. What is the length of RS? Well, that's 12. Plus, what is the length of ST? Well, that's 4. And that's going to give me the length of RT. RT is 16. So again, you were right in that RT was 16, but you jumped right to here, again, because that's usually been your focus in the past, but I'm focusing on, geometry is focusing on steps 1 and 2, and this is step 1 and 2 right here. This is geometry right here. This is a geometry course, so that's what you're going to be graded on more than the algebra part of the course, because algebra, you've already had that course, and we're doing geometry, okay? So it's very important that you follow these steps. You look at the figure, you write the expression without any numbers, without anything from the problem other than your understanding of the definition, postulate, or theorem, and then you can go ahead and substitute into these other ones, and finally, and finally determine the actual value, all right? So again, if you just write RT is equal 16, yeah, that's right, but you skipped all this, and this is what we're grading you on more heavily than the final answer. Let me give you one more example of something that looks like this, or a way to use this. So here I'm given AC is 60, AB is 20, so what is BC? And again, most of you could probably very easily go, oh, that's easy, BC is 40. Okay, again, but you have jumped down to here and skipped all of this. And again, this is the focus of geometry right up here, so you have to start here. So I start with the same thing. Okay, AC, I recognize that's a line, B is in between, so I know that these two parts added together equal the whole thing. So I understand it, so now I'm going to write the expression AB, the first part, plus BC is equal to AC. And how do you know that? Well, because of the segment addition postulate. Okay, so again, I start with geometry, steps 1 and 2, understand and write. Now I can go in and put the numbers in. So AB is 20, so that's 20, plus BC, that's X, equals AC. I'm told up here that AC is 60. Now I can go ahead and subtract 20 from both sides, so x is equal to 40. That's a 0. So x is equal to 40. So yes, I arrived at the same answer that I got without writing all this down. But again, what's the focus of the course? The focus of the course is right here. Because again, this is geometry right here. This down here is all algebra, and you've already passed the algebra course. We're in geometry now, so this is my focus. This needs to be your focus. Okay? On the next video, I'll do a couple more examples from this. They're a little bit more complicated, and then we'll wrap up this lesson.